Welcome dear grade 9 students, and here we go with the first chapter for this year, which is called the real numbers. So as you see symbols here, we are concerned mostly in this chapter in radicals, rationals, and irrational numbers. First of all, we are going to recall what you already know about numbers, about integers, about decimals, about rationals, and I'm going to give you a little bit details about what you already know about radicals from grade 8 and more new ideas about radicals, their properties, and more stuff. So first, let's make a brief revision for what we already know about numbers. Let's start with the whole number. So a whole number is a number that has no sign, no decimal. As you know, it is a number of the element of the set n. It's an element of the set n that starts with 0, 1, 2, 3, not. All the numbers are without signs, without decimals, without fractions. They are just whole numbers starting from 0, and they are infinite as well. Now, the set of natural numbers differ from that of whole numbers by something that 0 is not included in the set of natural numbers. Okay? So the set of natural numbers starts with 1, 2, 3, and etc. Now, we are going to talk about the integer. The integer is a natural number that's signed, that has a minus sign or a plus sign. So an integer is an element of the set z. So the set z is the set containing the integer, starts from minus infinity till plus infinity and moving by minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. So as if you are moving on the number line from minus infinity to plus infinity without the decimals or the fractions or whatever. Note, any whole number from the above can be considered an integer because any whole number can be preceded by a plus sign. Okay? A decimal number now is an element of the set D. So the set of decimals is called D, which contains the numbers with a decimal point, numbers having decimal point, a decimal part, an integral part or integer part, and separated by a decimal point. But there is an important property for the decimal number, is that the decimal part is limited, as you see here. So the decimal part, the part after the decimal point, is limited. So what makes a number a decimal is that it's terminated after the decimal point. There are also what we call by decimal fractions. Decimal fractions such as, for example, 2 over 5. For example, 7 over 20. If you use your calculator to get the result of 2 over 5 or 7 over 20, or for example 9 over let's say 25, you will notice that these will give you numbers, decimal numbers, that are terminated after the decimal point. Why? If you notice the denominator, and this is a revision also, the denominator here is 5. The denominator here, if we decompose 20, I will get 4, which is 2 squared times 5. So notice that the denominator includes a power of 2 and 5. 25 is 5 squared. So when the denominator contains 5 or 2 or both together, or powers of 5 and 2, or when the denominator is 10 and the powers of 10, for example 17 over 100 and so on, all of these examples are examples on decimal fractions that when changed into numbers, they will give a decimal number that's terminated after the decimal point. Okay? Now some numbers, like for example 0.333, 1.1212, etc. You notice that there is a repeated part. Here the repetition is for 3. Here the repetition is for 12. When you have such numbers, these numbers are not included in the decimal set. They are not decimals. They are called rationals. They are elements of the set Q. So Q from quotient, quotient from ratio, for example. So the set of rationals Q is the set of all numbers that can be written in the form of A over B as a fraction, where A and B are integers. Okay? So these numbers that are not considered as decimals are considered as rationals because they can be written in the form of a fraction, as you know. 1 over 3, if you find it using the calculator, you will get 0.333, etc. Because if you remember, 0.3 bar is going to be written as 3 over 9, and once simplifying it, we will get 1 over 3. So this kind of numbers can be changed into fractions. That's why we can call them rationals. They are found in the set of rationals, which is Q. Let's continue to know more about numbers. What about numbers that cannot be written as fractions? But before, let's make a little revision for prime numbers, because you are going to use prime numbers in decomposing radicals. What's a prime number? A prime number is a number whose only divisors are 1 and itself. Examples: 31, 17, 19, etc. So prime numbers, as you know, surely you know that, have only two divisors, 1 and the number itself. Here is a note that 2 is the smallest prime number and it's the only even one. So 2 is the smallest prime number and not 1, and that's a common mistake that most students do. They consider that 1 is the smallest prime number, but actually 2 is the smallest prime number and it's the only even one. Note that 0 and 1 are neither prime nor composite numbers. Now let's start with talking about the irrational number, and that's our main idea in this chapter. What is an irrational number? An irrational number, as I told you, cannot be written in the form of a fraction. So the rational number can be written in the form of a fraction, and let's remember, rational is from the word ratio. So the irrational number cannot be written as this form, A over B, where A and B are integers, such as radical 2, radical 3, radical 5, pi, etc. Whenever you find these numbers on the calculator, you will get a number, point, decimal part that's not terminated, so we can't call them decimals as well, because after the decimal point the numbers are not finite.